Hello and welcome to a look at covariance and correlation with me, Andy Duncan, here at FinLingo.com. If you're happy calculating a standard deviation and you know the difference between a population set and a sample set of data, then continue with this video. Otherwise, you might want to check our other video on standard deviations before coming back to this one. So what is a covariance? Well, it's a way of trying to figure out how closely related two different investment types are over time. Once we've got a covariance, we can then work out a correlation between the two investments. So what's a correlation? Well, a correlation of +1 means two different investment types are behaving identically and moving together. A correlation of -1 means two different investments are behaving in a completely opposite way to each other. On the other hand, a covariance of 0 implies a lack of any relation between the two different investments. Correlation, by the way, can never be above 1 or below -1. Here, I've plotted two sets of returns from two different investments. In the first investment, we've got returns of 4%, -3%, 6%, 5%, and -2%. In the second investment, we've got returns of 1%, -6%, 10%, 2%, and finally -4%. They do look pretty related to me, so let's guess that the correlation is near to 1. But let's just check that on a cunning spreadsheet. I'll input those figures again for the first set of returns. So that's 4%, -3%, 6%, 5%, and -2%. And the second set, 1%, -6%, 10%, 2%, and -4%. I'll assume you do know how to calculate all the standard deviation types. If not, go watch that video. The important part of this table is the covariance column. To get that first figure, we take the first return from the first set minus the first average. Then we multiply this by the first return from the second set minus the second average. And then we do that for the other 4 pairs. Once we've got all that done, we add them all up. The population covariance is then this sum divided by n, or in this case 5. The sample covariance is the sum again, this time divided by n-1, or 4. The correlation for the population is then the covariance divided by the two relevant standard deviations multiplied together. And the sample covariance follows the same process, but this time we use the sample information. A high positive correlation of +0.9 does tell us what we already knew. These two investments are highly correlated, but now we know exactly how correlated. We have a number. So let's try a question on FinLingo. This one's a population question and we're given all the key numbers in this table. Let me just copy that supplied table onto the spreadsheet. From the supplied information, we can now work out the two population standard deviations. Next, we work out the population covariance, then we divide this by the two standard deviations multiplied together. This gives us a weak positive correlation of just 0.32. Back on FinLingo, select the right answer, and we're done. But let's just do a sample question for fun. This one covers a sample as we can see. Again, I'll just quickly reproduce the table. So now we calculate the standard deviations, we calculate the covariance, we divide the covariance by the two standard deviations, and now we get a correlation of 0.92 for the sample. This tells us that the two investments are highly correlated. In other words, they move together. Now, head back to FinLingo, choose the right answer, and check the calculations. Head on over now to FinLingo.com to get an infinite number of questions on covariances and correlations, along with hundreds of other CFA question types. FinLingo. Speak finance fluently.